All right, now the setup is done, and then let's start. Yeah. It's very hard to use Zoom and PowerPoint. I don't know why it's got skewed because I just teach one of the class and then move to here, but it didn't work in the year. Sorry about that. And today is the last class, and then we will go over something about the malware. But at first, I tried to design this lecture to be more defense-oriented, but it turned out to be like more likely introducing all the cybercrime stuff. Yeah, so it'll be fun. Yeah. So the topics for today is about the malware, and then like we will take a look at the malware in a nutshell, and also we will go over some of the example malware attacks to see what are the final effect of the software sophisticated software attack, and then we will also discuss about some state-sponsored malwares, and then we will basically learn about the real cyber attacks and what are the threats. So malware is just a malicious software. The word itself is malicious software, malware. So the software that does malicious activity. And then what are the malicious activity then? Yeah. So getting into victim's computer with the unauthorized access, and also running a surveillance on a user's device. And it could be the stealing the password and then get access to the account, or encrypt the data and then ask for ransom. That's quite frequently happening in these days. And also like some passive kind of attack could be getting into the victim's machine and secretly running cryptocurrency mining stuff. So it's actually stealing the electricity and then those kind of things that yeah, looks like a little benign, but there are some spectrums of the attack that the malicious software can do. Then let's take a look at how malware operation goes in a very high level, and then let's get to the details. So I just put that there is some of the attacker, and then over the internet there are a lot of machines available there. So because like we can easily assume that most of the computer devices are connected to the internet. So to spread the malware, the attacker just write a malware. And writing a malware is very simple and easy. So if you just write a program that delete everything from your computer or something, that's a malware too. Yeah. So the writing the malware is not the difficult part, but the spreading the malware is the difficult part at the start. Yeah. So after writing the malware, so the attacker need to find some of the exploits. So working exploits from like the unpatched vulnerabilities. If there's a no patch, then they can attack all the products. But there could be a patch has been released. So for that kind of vulnerability, we call that as a one-day vulnerability, right? And then even for one-day vulnerability, if there's many people who did not update their software or operating system, then it will still be active. So find one of that, and then shoot the exploit over the internet. So it's something like shoot the exploit and then infect one of the machine. But after infecting the one of the machine, so there's a way that the attacker keep finding the target and attack again and again. But if they do so, then there is a single center point, shoots the exploit to all the other world, then that will be very eminently shown on the some of the state governments the surveillance system for the network monitoring kind of thing. So to avoid that kind of thing, what they are doing is they actually write the malware to propagate by themselves. So it's a software attack, so the attackers don't have to launch the attack directly. So after getting into one of the machine, what they can do is this malicious software sticks for another target. And then if there's another computer, hack it and propagate. And then it can go on and on. But the important point here is that the attacker just infected one machine at time 1. At time 2, it became 2 machines. At time 3, these 2 machines are attacking another 2 machines. 4, 8, and then many. So you will see that it's something like a one person. It's not a person, like one object, like can have like 2 offsprings and then do it again and again. So exponential growth. So I just want to demonstrate that even if like the attacker just shoot one exploit, then if they wrote the malware to infect another machine by themselves, then like we can easily trigger this kind of the exponential growth of the attack. Yeah, and then that's how the early days of the malware was working. Yeah. So eventually the attacker can have like the many computers infected by their malware. And then at the end of their malware, the attacker put the code to, after finishing the attack, connect back to one of their server. And then to avoid any kind of tracking from the law enforcement, this server might be hacked one too. So for example, attacker can hack one of the Oregon State.edu server and then use that as this kind of server. And then all the malware will be connecting to that server. So it'll be something like this. So conceptually, what attacker have done is like this guy generated a lot of servant and then spread out all the malwares in there. And then it will wait for the attacker's command. Then if they send command, then they will operate on the victim's machine. Yeah. So for example, attacker can send the command that, everybody connect to the Oregon State.edu website for 10,000 times. Yeah. Then they will all connect to the Oregon State.edu. Then this is a so-called distributed denial of service attack. Have you heard about this kind of the DDoS term? Yeah. So if you have heard about like a DDoS attack launches, something like that, then like DDoS can be launched by like the different region, like there is some of the systems, and then they are sending messages to each other, and then like the attackers may trigger a bug in a protocol for amplifying the number of messages. But this case is a different one. That's the more like the systematic DDoS kind of attack. This is more likely the malware-based intentional attack. Yeah. So what happens to our server if attack is launched? It's something like we may get 1 million requests per second, or I'm not sure how many requests of the Oregon State.edu server gets, but what I know is like the modern servers to support like 1 million requests per second, I believe they have to use like a 32 core or more machine, the more powerful machine for that. Yeah, but if our servers are limited to handle 10,000, like 100,000 users per second, then what we will see is like the packets are keep gathering together. So like we need to handle requests, but the request handling could be a mass, like it's something like that. Yeah. So here, the writing the malware was easy at the start. So nowadays it's super difficult because we need to defeat some of the mechanism that the antivirus or that kind of security monitor does. So attackers need to write the software to look like a normal software. And then there are a lot of techniques to do that. But in a nutshell, so the writing the malware is very simple. So if I write this kind of program, and then what it does is like this command is, so I just run 2 commands. This command is removing all the files starting from root recursively and forcefully delete everything. Yeah. So even if you are not root, it goes over all the file system. And then if you can delete that file, it will be deleted. And then the second command is like if there's a sudo, the root privilege, then what it runs is a dd is like I don't know the full name of the program. And so what it does is like a disk duplicating or something. Yeah. So options are like the if is like the input file and OF is the output file. So we get the input from dev0, and dev0 in Linux always, by default definition, it returns all 0. And then reading from 0 and then writing to the SDA1 is the first hard drive and then first partition. So what it does is actually the putting all 0 to your disk. So it's something like wiping your disk. So this is actually an attack. Yeah, but if you write this program and then like run it with the antivirus, they will not catch this as a malware at all. Yeah. So there's a there's a limitation of that, and then maybe let's discuss about the antivirus at the end of this lecture. Yeah. So I want to emphasize that the writing the malware is very easy. Yeah. Then difficult part is like how attackers can propagate malware to have the number of armies of the zombie computers. Yeah. So one of the way of doing that is a hard way, and that's we can do that via software attacks. So we have learned that it's very hard to avoid the software attacks, and then there are a lot of zero-day vulnerabilities discovered each day. So if we know one of the thing, and then if the patch Tuesday has not come yet, that is like December 13th for the next month, right? So if you have a Microsoft 0-day today, then if that is, even if that would be patched in the patch Tuesday, then still you have a 12 days of the Windows to the actively launching the exploit. Yeah. So the attackers can have like that kind of advantage of like the patch delay time. In that case, like that they can attack the victim, the server. So to demonstrate some of the working scenario, so I want to be realistic. So I searched on the web about like there was like a malware exploits or something, but there was a malware exploits for the IP camera. So some of the we can easily purchase like the IoT camera for like taking a surveillance on the home. And then they do open the port, and then they do have a server logic. And then if not updated well, then that can also have the vulnerability and got hacked. Yeah. So I will explain the scenario as like the attackers want to mass exploit on the certain IP camera. Then that attacker just search on the internet. So the attacker suppose the attacker don't know how to develop the zero-day exploit. Yeah. Then just search on the internet, then they can find this kind of information. Yeah. And then the attacker's main target is someone who did not patch on time. Yeah. And then after knowing this kind of thing, so if I visited this website today, and then like the description of that blog article thoroughly describes about like what kind of port the IP camera uses, and then what was the vulnerability, and then how to attack that. So for the educational purpose, they disclose everything. Yeah, and then that's a good thing because we can, as a security researcher, we can learn about those kind of attack, and then because that kind of attack has been reported and then publicized, then like as a defenders, we can develop the good defense because we know what is the cause of the attack, what are the effect of the attack, we have a full knowledge of that. But the problem is that the attackers may have the same knowledge. If we can access, then they can access too. But the problem is that there are some poor victims who didn't update the thing on time. So the attacker tried to analyze the target. So they can get the information from the website with blog article or something, or they can purchase the same device, and then at their home, they try to test it. What kind of ports are opened, whether their exploit really works or not. But depending on the case, they need to adjust a little bit. Yeah. So we can easily assume that the attackers can easily get a working one-day exploit. Yeah. And then next is searching for the targets. So we know that some of the IP camera has a vulnerability, but we don't know which IP addresses are available for those IP cameras. But don't worry about that. There's a service for that. So there's a service called Shodan. And then this is a search engine for vulnerable hosts over the internet. And then You might feel that why that kind of site exists. That makes attack easy, right? But the main purpose of this website is to figure out how many of the vulnerable devices are there or in your own network. And then after figuring out, as a network administrator, we can ask them to patch. We can ask them to fix the thing. Or for those kind of the services, if we cannot contact the administrator of that server or something, then as a network administrator, we can set a network firewall to not allowing any kind of connection to specific port. So we can do that kind of defense. Yeah. So this tool is like there for helping the kind of the network operators, but at the same time, it can be used for searching for the attackable targets. Yeah. So this is the example of the thing. And then I actually have some IP camera and then port 8800. That's my search term. And then so the goal is clear. So I searched for the IP camera vulnerability, and then the port opened was the 8800. And then I got that information from the blog post. And then if I search that on the Shodan, then I can see that the more than 5,000 results. So the more than 5,000 of the such devices are available online. And then from the map, we can identify that that's spread out all across the globe. Yeah. So if the vulnerability is 1 day, not all the devices are affected by the attack. But if the vulnerability is 0 day, then we can hack all the machines. Yeah. So what I'm demonstrating is that the attackers can easily find attackable targets if they obtain the exploit. Yeah. And then Shodan is not the only services. There are some other service called a criminal IP. Yeah. And then Census and the Shodan. These three are like the representative, like the search engine for those kind of the vulnerable host or something. Yeah. And then to introduce things a little more. So this work, criminal IP, was the latecomer. The Shodan was the first one, and then Census was developed from the University of Illinois and University of Michigan. So the Census is from the academic work, and then Shodan is from the industry work. And then criminal IP wants to beat these two companies. So what they are actually support is interesting. So this is the result, one of the results that I clicked on some of the vulnerable hosts. And then the most important thing is that I'm not sure you can see the characters here or something, but what it says is like it has 22 vulnerabilities. Yeah. So how it knows about the target device has 22 vulnerabilities is that what they are doing is that they are actually doing the port scan. So for every IP address on the internet. So we have theoretically 2 to the 32 machines, the IP addresses for the IPv4 space. Then they are actually, every day they try to search every IP address for every port number. Yeah. And then they try to collect what kind of port numbers are available. And then they also connect to them. So for example, have you connected to our VMCTF1 server not using SSH or something else? So if you so SSH uses a port 22, and then if you connect to the SSH using the raw, like the TCP socket, then it will say open SSH version 7.2 or something. Yeah. So what that means is that, so if there's a port opened, if we just connect it and then receive what server says, then they say about the version number. Then if that is like HTTP traffic, then in the HTTP response header, they also say Nginx version 1.43.0 or something. So that means this kind of the scanning can obtain the version number, and then version number is written in the CVE report, right? And then from the CVE database, we can join it and then try to figure out like which CVE matches to which service version. Then we can easily enumerate all and then how many affected vulnerability CVEs are applied for that specific machine. And then if I click this 22 vulnerabilities, then this website also shows that what are the each vulnerabilities, and then what are the each CVEs. And then in case there's I'm not making you to launch the real attack. I'm just demonstrating how to do that. So don't try this at all. So what you can do is like that. After clicking one of the machine, there are vulnerabilities, and then it kindly shows that all the CV numbers. And then if you just search this CV number and exploit on Google, and then sometimes it does not show up, but you will eventually see that the one thing comes up. Then get that program, attack it. Then you will have like a very high chance of the success on the exploit. But the important thing is that getting into others' computer without having proper access is like illegal in the United States. So yeah, it's a legal disclaimer for protecting myself. Then this is a census, and then census is more about like the academic work. So like these are much more free from like the giving more about like the vulnerability information or something, but they are mostly focusing on the providing the what kind of port and then what kind of services are running, but that they do not have explicit services like the CV and the vulnerability matching kind of thing. Yeah. So there are search engines. So then finding the target IP addresses are easy. So we can do that, and then we can launch the attack to those machines. Yeah. But there could be a problem. Yeah. So as a network administrators, we can set some of the countermeasures. So what I want to tell you here is that not all computers on the internet can be connected by the computer from the outside on the internet. So what that means is that, so if I go outside the campus and then try to connect to the OregonState.edu website, then that's allowed. But if I go to somewhere else and then try to connect to one of your laptop, even if I know your IP address, yeah, I cannot connect to there. The reason is Oregon State University, we have a security team in the IT side. And then we have a security operations center. And then we set a firewall that the outside commerce cannot establish connection to your laptop. So how it works is something like, as a laptop user, connection originated from your side can be established. And then after established it, they can communicate. But if the connection is originated from the outside to your laptop, that is blocked. Yeah. Because attackers can easily launch attack like this. Yeah. So many of the companies or organizations, or even for the Wi-Fi router, yeah, they do use this kind of techniques. So even for the Wi-Fi router in my home, so I use the simple one. Yeah, not the super great like the $1,000 one. Is just a $50, and then it has a functionality, same functionality that all the connected devices are using internal IP address, something like a 192.168 something. Yeah, I believe like some of you have seen that kind of IP number, and then that is like an unassigned IPv4 area. So that's actually just for like the internal network. And then even if we know that IP address, because that's the internal one, so we cannot connect from the outside. Yeah, so that's good. But attackers will never give up if there is a firewall, and then if there's some of the good things hidden behind the firewall. So what they can do is, so let's assume another scenario. So Youngjun is using the laptop, yeah, in his home, and then suppose he's using the 10-year-old not updated Wi-Fi router, and then so the Wi-Fi router, and then my laptop is connected to the Wi-Fi router, so the firewall is at the router, so that will protect my machine. But suppose this router has a vulnerability, then if that one got hacked, then the attackers can do anything, right? So that's the thing. Then attackers can easily search about the Wi-Fi router vulnerability, and do the same thing on the Shodan or other like the website and search, then eventually they can figure out my IP address that router has. And then first step for them is like a hack the router. And then after getting into the router, then now the router can connect to the internal network naturally because they build a network. Yeah. So they can hack my not updated MacBook Pro. Yeah. And then this is owned by OSU. And then some day later, I have to come to school Tuesday, Wednesday, Thursday for like a teaching in this class. Then now the malware can hack your machine. Yeah, because we are all under the same Wi-Fi router at the end at there. Yeah, and then if we are on the same network internally, we can send the packets. Yeah, if there's a no good file or Waluru isn't working in there. Yeah, so in that case, like the attackers cannot attack your laptops, but by having multiple hops, then they can have a mule to send some of the attacks to the physically in this space, and then the I might be the dead mule if I carry the malware. Yeah. So, and then this is the hard way for spreading the malware. The reason is, so this method requires so for the one-day vulnerabilities, it's quite easy because we can search on the internet and apply that. But for the zero-day vulnerability, so if one found the zero-day vulnerability, they can sell at a high price. Yeah. So in that case, like the better to get the kind of the bounty than launching the attack. But for some people, they don't care about the money. They need to do some of the attack, then they can spend an unlimited amount of money. Then for them, the acquiring exploit might be easy. Yeah. And then not for this case, there are more easier way to propagating the malware. And then that is, so I told you the writing the malware is easy. And then instead of like seeking for the exploit, you can construct a website. And then like saying that, oh, there are a lot of freebies. Yeah. Then people will come. And then ask them, oh, there is a program. If you install it, yeah, I will give you Bitcoin. Yeah. And then if they install it, the game is over. So that what attacker wants to do with the exploits is that just running a single program in there. And then to just run a single program, hackers are doing research a lot for the several $1 million thing. Yeah. But without doing that, you can actually ask them kindly, oh, please install this. Yeah, that happens. And then this is the one I just searched. I believe this is a legitimate service. Yeah. So what I searched is like the Windows 10 free download on Google, and then you can easily find this website. And then from here, I just want to download the disk image. But what they say is that download and install their own program. Yeah. Why? I don't know. Yeah, but there is a reason, because like for ISO files to actually install the operating system, you need to bake it to the USB driver or something. So that there could be some of the users who don't know how to make the ISO to USB. So I believe this program itself is something like that. But what I want to give an example is that like I've seen a lot of websites that they just give away the classical games or like some of the utilities. Then like if I want to download that, then I need to download some of their company's program, then it will give away the actual program. So as a user, end user, you will get the final result, but in the middle, you will have the unwanted program in your machine, and then that could act as a malware. Yeah. And another way to running malware inside the victim machine without exploit is phishing. Yeah. So this is the one of the message, and then I got 2,000 Bitcoin for Christmas. And then what they are saying is that there's a secret desktop software, and then it will give you thousands of dollars every day. Download and install. The game is over. Yeah. So the implications are there are many zero-day vulnerabilities are discovered in a day. So even for the hardware, there are many chances that attackers can launch the attack. And then if they have an exploit, they can easily find the target using the online search engine for the victims and then launch that. And then there are more easy way to launch that. So not hacking the computer machines, but more likely applying social engineering to ask humans to do so. Then because our goal, the attacker's goal, is just making the program installed and running. So we don't have to do that in a programmatic way. And then to list about like some of the potential ways that we get the malware infection is that one thing is that we can easily search about the one-day exploit. So if our system has not been updated, then yeah, that's the height that will increase the chance of the getting attacked. And then like from the scenario, if I use the old Wi-Fi router, that could be also like the potential like the risk. And another thing is like if you connect to the rogue Wi-Fi router, then they can attack your machine. And then the example case is that when you go to Starbucks, and then there's a Google Starbucks Wi-Fi, and then that's not patented or like a trademarked or like so that anyone can open another Wi-Fi router, or like I can even use my iPhone to make the hotspot name as a Google Starbucks, and then everybody will connect to my one, right? So it is very important to like distinguish like the not connecting the rogue Wi-Fi router, and then the never install unknown programs. Yeah, and then like that. I've seen that many of the non-computer studying users, if they have seen that like there's a yes/no dialogue, they just immediately click yes. Otherwise, the website will not give like what they want, and then they are trained like that. And then even I sometimes do that, but I intentionally run those kind of things inside of the running virtual machine, and then get the fruit, and then like they waste all the others. Yeah, that happens. But for the regular users, like it's quite exposed to that kind of attack. And then so there could be SMS messages or email messages that send the link, but clicking the link means that your web browser will be connecting to some of the website that you don't know. And then if the web browser has a vulnerability in their JavaScript engine or something, then that website can hack it, and then get into the thing. So in the last lecture, we learned about the zero-click exploit is expensive, right? The reason is zero. If the attack is zero-click, then user don't have to do that, and then attack is successful. But if it is not zero-click, then they need to send an SMS message like there's an election on the November something, and then there's a flyer. Then if they click it, then yeah, the attack happens, something like that. So I highly recommend that never click on some of the link that the unknown people have sent. And then if you have to click something or want to see what are there, and also if you get a spam message that you purchase a lot of items and there's an invoice, then never open the PDF file with your main computer. Yeah. So for those kind of stuff, please always prepare one of the virtual machine. And then the secure way to access that is like for the virtual machines, for example, the VMware or VirtualBox, those kind of thing. You can run the operating system inside of it. And then another good feature is that there's a snapshot and restore. So what we can do is, so let's get the link for the unknown attacker sent link. And then in the virtual machine, we take the snapshot first, and then connect to that website. And then we don't know what happened. There could be an attack or something. Then after seeing that in the content of the PDF or something, we restore the snapshot. Then anything that the malware have done will be erased, because we just time travel to the past for the older state of the machine. So what I recommend for like opening some spooky, sketchy PDF links, then prepare a virtual machine and snapshot or restore. that's how you can protect yourself. And then for the next, so before moving to the next to see about like what kind of the malware attacks happened in past, is there any questions about the malware propagation and this kind of attacks? No? Yeah, then let's move forward. So the first recorded malware attack is called the Morris worm. The name Morris comes from the last name of the author, Robert Tappan Morris. And then he was a grad student at Cornell University in 1988. And then he hacked the machines at MIT. But and then interesting thing is that after hacking the thing, and then he's now professor at MIT. Yeah, I'm not sure how that happens. Yeah, but no, one thing to tell you is that in old days, there are some of the rumor that if you hack NSA, you will be hired by NSA. Yeah, nowadays that's not applied. If you hack NSA, you will be suffer in jail time. Yeah, so don't do that. Yeah, so it was 1988, so that can be worked. But, and then the interesting thing is that so they exploited the buffer overflow vulnerability in FingerD, and then some other like the setup related, or also like they try to steal the weak password. Yeah, so that's the attacks that the originated Morris worm did. And it has a functionality that after one attack happened, the malware on the victim machine will try to search for the infecting another host and another host. So it hit the exponential growth of the thing and then broke some of the network related systems in the university. Yeah, that's the attack happened. And then like if you read through some of the things written in the Wikipedia, you will realize that that kind of the exponential growth has happened because Robert Morris was aware of that kind of the behavior, but he didn't put the stopper. So it grows exponentially, and then like caught by the law enforcement. And then they have gone through all the legal trials or something. So yeah. So that's the first one. And then the next remarkable one is in 2003. So the 1988, there are not that much computers at home was connected to the internet. But in 2003, it's a little different. That's the era of like a Windows XP and Pentium 4 or those kind of era. And then like in January 2003, there was a bug in the Microsoft's database server. And then interesting thing is that, so at that time, there is an operating system, Windows 95, Windows 98, and Windows Me. And then these are desktop normal user operating system. And then there is a Windows 2000. That's the server operating system of the Windows. And then these operating systems, the Windows 95, 98, they don't support multi-core. But the server operating system naturally supports multi-cores. But Microsoft realized that the future is with the multi-core operating system. So their next version of the operating system is a combination of the Windows Me and Windows 2000. So that's the Windows XP. So the reason why I'm explaining this is that, so in the most of cases, normal user's computer, there's no database server. But the Windows XP is the combination of the server OS and the user OS. So they ship the Microsoft SQL server even for the regular user machines. For the home edition, yeah, they do have that. And then there was a buffer overflow vulnerability here. But the interesting thing is that this attack happened in January 2003. And then the vulnerability was reported in July 2002. Yeah. So 6 months ago, there was a report, and then they released a patch. And then many organizations have not applied that. And then not just for the organizations, I told you that the Windows XP, the regular user machine is the thing. And then can you guess how many of like the update on everything on the Patch Tuesday? I bet on like the very small number of the users who do that. And then even for the 6 months later, yeah, we could have like a lot of people, a lot of computers, yeah, available for the attack. So they use the similar method and then attack one of the hosts, and then that host attack another, and then so on, so that they can easily get like the 75,000 victims within 10 minutes. Yeah. And then within a 10 minutes was that. And then after a day, entire South Korea's internet was taken down. So I was in South Korea at that time, but unfortunately, I could not experience that kind of thing. The reason was, I entered the college in the March of the 2003, and then before entering the college, I have to go to the voluntary community service to fulfill some of the requirement. So that I was at there, so I'm not allowed to use computers at there, so that I don't even know the internet is not working. Yeah. So that was very unfortunate moment as a security researcher. So I could not see that kind of moment. It's something like that. I missed the total eclipse kind of thing. Yeah. But from the news, I can see that the internet is not working. But at that time, I was not a security researcher. I don't know what's happening. But now I know. Yeah. And then, so the implication is that even for not a zero-day exploit, one-day exploit, we can have like this much of the victim in 10 minutes, and then we can take down the entire nation's internet. And then not just for South Korea, so US internet also got slowed down like drastically. So like this has been recorded as a serious attack. Yeah. So what happened was like the worms are not actually attack some of the other website. And then what they are doing is they just keep spreading. Yeah. Then it's something like to launch the attack, suppose we need to send 5 packets to launch the attack. But at time 1, we will send 5. Time 2, 10, 20, 40, exponential growth. So we have many routers on the internet, and then they are actually forward packet from one to another hop. So the internet routing is not like if I set the A and B, it directly goes to A from B. No, it should go through like multiple hops of the routers. And then at each hop, so depending on the traffic volume, routers are deciding that where to send this packet. So that kind of decision is made in real time as the packet arrives on the router. But in this case, because the malware generates a lot of traffic, exponentially growing for the attack traffics, so the sum of the router cannot handle that. But if the routers are well programmed and well designed, so even if the volume is too much, then they just got slowed down, but they keep making the progress. But some of the routers didn't test it well for that kind of extreme scenario. So some of the routers got failed. Then, if they are not responsible, they are not sending any kind of response, then some of the router are ahead of like one hop ahead of this router, then they need to decide to send that packet to another router. Then suppose we have 10 routers, and then 5 of them died. Then the rest of the 5 will get twice more traffic. Then they will make some more die. And then there is a chain reaction of the taking down of the many routers on the internet. And that's why the internet was disconnected. Yeah. And then like entire South Korea's network was eclipsed. Yeah. And then nobody in the world can connect to the South Korea for 8 hours, I believe. Yeah, that happened with that one. So the implication is that this kind of the exponential growth of the attack is very severely damaging our routers. And then as a human, and then in reality, we don't have the exponentially available resource. Most of the resources are increasing linearly. So that means like we cannot put exponentially more routers, yeah, to the infrastructure. So yeah. So even not launching the attack, by just interacting with the other machines, the malwares can launch, take down the internet. That's the implication. And then we keep seeing that something similar to the DDoS attack, right? And then DDoS attack can slow down the systems, yeah. And then attackers may launch that. Then what is the attacker's gain, reward, motivation for launching DDoS attack? So the DDoS attack is not like that I steal some of the information from them, I steal money from them, but it's more likely making their system not working. Yeah. Yeah. But there could be a case that so suppose like I want to disturb Google's business, then like I can send an email to YouTube head, then and I will launch the DDoS attack on YouTube, and then you guys have like the very important broadcast on like a Google I/O on like a certain day. Then to avoid that, pay me $1 million. So that kind of deal can be possible if you target a big tech company, and then who has the money, and then service availability is very important. So makes sense if they hack the yeah. All right. So the reason the thing that I want to describe is that, so let's put it a different way. So suppose attacker hacked one of the regular user machine, but assume that we are living in year 2000. At that time, we didn't have smartphone. And then we didn't have like a many website accepting credit cards. So there's not that much like the online financial services, that kind of thing. So in that case, attacker, if they hack the user's machine, then there's not that much private data. There's no credit card information. Yeah. Even if you steal a password, you cannot purchase it. There's no online market. Yeah. Much of the online market at that time. Yeah. So what I mean is that there is no advantage to attackers to attack regular machine. So for example, if they attack the Google's server and then steal secret information out of that, then that's super valuable, and they can sell it to the competing company with a high price. Yeah. But if they hack the regular user machine, they cannot earn the money. That was the problem. So mostly the hacking's target was like the high profile server, but by launching the DDoS attack, they can earn the money. As I just explained, that like if there's a big tech company, take care about the service availability, then blackmail them. Yeah. So these slides are like the describing about like the era without smartphone and the regular user computers and have not that much valuable information. Yeah. So they just launch DDoS attack. Yeah. So, and then entire logic is that the hacking high profile server is difficult because they do have a good security team and they're managing the server or something. But most of the small businesses or individual users, they do not have their own security team. Then like it's often like that they don't know about like how to build the security on the system. So they can be easily be attacked by the attacker. But for the attackers, there was no advantage to attack them because there's no way to get paid back or something like that. But one way to get the money is infect a lot of hosts and then launch DDoS attack and then blackmail them to get the money. So one of the interesting case was that, so the country Estonia, they actually runs all the election over the internet. It's not about the e-voting. So in the US, to vote, we will use the electrical machines, but it is completely disconnected from the internet. But in Estonia case, you can actually vote. If you just connect to the internet, if you're in the US, you can vote for Estonia. Yeah, that's possible. And then one of the virtual scenario could be, so I believe I have seen some of the news that actually the Estonia got this kind of the blackmail, but I'm not sure that they paid the money to the attacker or something, but a hacker can, who own like suppose like the 100,000 victim machines, zombie machines, then they can blackmail Estonia government that from start of the election to the end of the election, we will launch the DDoS attack. And then give me $1 million. And then they may not pay for that. Then what attackers are doing is that, so send an email, then from now to 2 minutes, I will launch the attack and then try to test your website and then demonstrate that the effectiveness of their attack. And then if the government officials cannot connect to the internet, and then if the election day is tomorrow, then better to pay that, right? Yeah, but they don't know if like even if they pay that, they could launch the attack. That's not guaranteed. So it's a sophisticated problem. Yeah. So in the early stage of the malware, yeah, what I want to tell is like there is no value of the hacking the small business or like a regular user's machine. So either hack the big company or a government machine, steal the valuable information, or hack mass of the dumb machine to launch the DDoS. These were like the attacks. But starting from 2007, that was changed. So in 2007-ish, that's where like all the e-commerce and then credit card payment, and these are all available. And then PayPal is also actively used in that era. Yeah. And then there's a malware called Juice. And then Juice malware, it specifically targeting stealing the financial information from the host. So in 2007, there's a feature that the web browser stores a password. So if we hack the regular user account, then we can use that password to use the user's stored credit card into the website. Also, if we can like take the moment of the users are typing their credit card number, then from the keystroke, we can steal that. And another scenario is that the Juice malware. So firstly, they target like the regular users, but their enhanced version targets the point of sale computers. So they specifically, I forgot the exact year, but it was like 2011 or 12. So the Juice malware targeting the Subway's point of sale machine, because they are running with Windows, but they're not updated. So like one of the hacking group hacked a lot of Subway branches, and then edit the revenue and also like steal the user's credit card information. Yeah, and then that kind of thing happened. And then in another statistics is that in 2009, Damballa is one of the company that analyzed the malware threat analyst or something like that. So this company is actually founded by my PhD advisor. Yeah, and then now it's not existing. So sorry about that company. But this company worked well for the defeating against this kind of the malware network. And then we call this kind of the network of the malwares that launch DDoS and then do the malicious activity as a botnets, because we call the impacted machine as a bot. And then Damballa was the world #1 at that era to like take down the botnets. So my thesis advisor went to Spain to take down some of the botnets called Mariposa with the Interpol. And then, yeah, that kind of thing was very fun to watch. Yeah. But the important thing is like this malware has been spread more than 3 million machines only for the US, and then damaged a lot financially for individuals and then for the small businesses. Yeah. So the things changed. Previously, DDoS, that targets the big companies. Juice, now it targets the small companies and then individuals. But the problem of the Juice malware is that, so suppose I hacked one of the credit card number, but if I use that in the 7-Eleven right across the street, they do have a security camera, and then they will see my face, and then the law enforcement can take down that. So it's very hard to take away the money, even if you launch the hack. So Juice malware requires an organized crime to get the money out of it. So how it is structured is that, so there are malware writers and then exploit writers. So they are hackers. And then hackers attacks victims. And then from the victim, they will steal the money. But if they directly use that money for them, then they will get easily caught. So they just borrow some other organized crime. They are very good at doing money laundering. So in the middle, they need to do the money laundering for the stolen credit card and that kind of info. So the entire crime works like this. So I will not describe this, but you can follow all the guidelines from the slide. And then, so it is also globally happening. So the attackers not in the US, yeah, from the European countries or somewhere else, yeah, that happens. And then, but the most of victims are in the US. Yeah, that's unfortunate. So the implication is that, so as the technology advances, the regular computers or small business computer, they do have they do have a point of sale connected to the internet. And then these computers are valuable because we can steal the credit card information. So previously things are not connected, but in this case, things are connected. So with the organized crime, the attackers can earn the money. Yeah. So it requires exploit writers and the money laundering service. And then the next level of the malware is so-called the remote access Trojan. And then another different name of this kind of thing is like a so-called exploit as a service. So remote access Trojan, often called as a RAT, yeah, these are more generalized version of Juice. So Juice is specifically coded in like the stealing the credit card information, but the RAT is coded to like the doing more general job. So have you ever used a remote desktop or a team viewer? So you can think of RAT as a team viewer. Yeah. So that you can do whatever you want on the victim's computer. Yeah. So the one of the business model is that if there's an attacker, and then if they have a connection to the money laundering mules, then they can directly launching the attack and then earn the money. But if the hacker don't know about like how to do the money laundering, yeah, then what they can do is they can actually write this kind of the remote access Trojan, and then one copy, $3,000. So that they actually sell the exploit kits. Yeah. So what that means is that, so even a person who don't know how to code, yeah, they can just purchase the exploit kit and then launch the attack. If they can use how to use the GUI operating system, because it will be like a team viewer, yeah, so they can hack. So that's why it is called as an exploit as a service. So you don't have to search for the exploit. There it is. Just get it and then pawn it and then profit. And then the next version of this one is ransomware. So the ransomware is available as an exploit as a service. And then there is a hacking group and then deliberately write the ransomware exploit and then launch it. But some other group actually just develop the ransomware tool and sell it. Yeah. And then the important difference is that end user computer in the early 2000s, there are not that much valuable private information, but in 2022, we do have a lot of valuable information that can be exploited by attackers on our computers. Yeah. And then that's the reason why the attackers are focusing on was not focusing on the user's computer in all days, but in these days, they can lucratively hack the end user. And then how ransomware works is that after getting into the machine, it tries to search for the available files and then encrypt them. And then ask for the money. And then if you pay that, then they will give out the decryption key. Yeah. So they actually made a new business model that does not require money laundering mule. because so ransomware, I believe like a ransomware attack is hardly happened, not like this. So it should be something similar to Juice, because right now ransomware is much more impacting, much more generating much more victims than Juice malware. And then I believe the reason is previously we need to have a money laundering mule to get the money. So like individual hackers cannot do that. But with the rise of the cryptocurrency actually supports easy money laundering. So you can just do the money laundering with few clicks if you pay like a 30 to 40% fee. Yeah. So because there is a way that the hackers can anonymously receive the cryptocurrency. So ransomware can be launched individually. So there are so many people runs a ransomware activity. So that's why we are seeing a lot of victims here. So in the cryptocurrency, specifically, there is a Monero, Zcash, and then another zero something. Yeah, these are all about the cryptocurrency that anonymize transactions. That means if I send one of the coin to one of the students here, then nobody knows who sent to whom. Yeah, and then by using that kind of thing a lot, then we can easily make the law enforcement hardly track down like the where the money goes. Yeah, so that's actually removing this part, so the hackers can directly attack that. Yeah. Then that's the one thing. And then writing a ransomware kit requires a little bit of like a computer science knowledge, but the problem is that ransomware kits are also sold. So some of the article says that the lucky ransomware for 3,000. So there's can be accessed through Tor network. Have you heard about the term dark web? So there is a regular website, and then there's a dark website, and then here mentioned about the Tor network. The Tor, T-O-R, means that the onion routing, and then the routing refer to the onion. What that means is that like if we have a network packet, what it does is like it will have multiple hops and then connect to the end host. And end host will never know who I am. That's the purpose. And then the reason why it is called as an onion is that, so in the Tor network, we have 3 hops. And then for each hop, we need to make sure that this host don't know what I'm doing. The next host should never know what I'm doing. The other should not know what I'm doing. And then the final server, they can know who connected at the end, but they should not know who are the middle node and then who am I. And then to implement that, we need to encrypt the data. So we have 1, 2, 3, 4 servers. So we need to first encrypt the data for this server. One encryption, another host, another encryption, another host, another encryption. So it looks like an onion that we are wrapping the encryption. So that's why it's called the Tor d-onion routing. And then if we serve website over the Tor network, then that means the law enforcement cannot track down us. So that's why the dark web was developed in there. So if you go download the Tor network or Tor browser and then searching for one of the dark web website, then you can easily see that they are dealing the exploits. And then they're also not just for the cyber weapons, the real physical weapons are all dealt in there. And then have you heard about the Silk Road? Yeah. So that was the weird website that even like they sell like human organs. Yeah. So I'm not sure like that will be delivered in the US or not. Yeah. So there are a lot of crazy websites like that. But the important thing is like then the dark web, one can easily purchase the ransomware kit. So we call that as a ransomware as a service. So in 2016, there was a ransomware kit. So as a attacker, we can just purchase it, and then we need to manage all the things. But the ransomware as a service. So there's a hacker group. They actually runs a cloud service. And then what the purchaser of the service, what they need to do is they just go to the web console and then searching for the target and then send it. Yeah. And then there is the easy UI that the email phishing or sending the link or that kind of thing. So even you don't know about the security or computer knowledge, then you can easily launch all the attack, and then that is serviced as a service. Yeah. So we are living in this kind of the dangerous era. And then before moving to the next topic, the Stuxnet, is there any questions about the examples of the history malware attacks? And then for Stuxnet, frankly, I couldn't prepare the slide, but I can explain the details of them. Yeah. And then let me start with the background of the entire attack. So the US government would like to demolish the nuclear infrastructure in the Iranian state. Yeah, Iranian state. And then so that facility is a high-grade security facility. So only person who has a security clearance can get in. And then the entire facility is disconnected from the internet. Then how can you attack that remotely? Yeah. Yeah. So there are many ways to do that. And then there are very sophisticated hubs. Yeah. And then the first thing US government did that is, so yeah, maybe I'm blaming US government too much. Yeah, let's use the attacker. Yeah, because in this case, they admitted that if they launched the attack, there's no legal disclaimer is required, but yeah, let's refer to the attackers. Yeah, so the requirement is that, so if there's no internet connections, then we need to get through the boundary, security boundary. Yeah, and then, so I just demonstrated in the slide that even if there's a firewall or something, if the attacker hacked my router at home, then that will hack my MacBook. And then if I bring this MacBook to here, then they can attack OSE students, right? The same thing happens. So they target weakest link in all the chain, and then that's the human. Yeah. So they try to launch a lot of attacks, and then it requires 7 or 8 attacks combined all together to successfully get into the nuclear facility. But the most important attack was the vulnerability called the LNK vulnerability. And then LNK is a shortcut, the extension of the shortcut file in the Windows. Yeah. So the shortcut icon on the desktop kind of thing. Yeah. And then we can put that kind of icon file in the USB drive. And then if we put the USB drive, then the Windows operating system automatically reads that kind of link to check if what kind of file it needs to be linked or something. And then there was a vulnerability in processing the LNK file. Yeah. But if that was reported as a vulnerability for CVE, so it will get the lower severity score because that requires a physical access to the machine. Yeah, to successfully attack the machine, one need to plug the USB drive to the physical machine. So because of that, attackers cannot easily have a massive infection of the device because there's a physical reason. So there has been a lot of that kind of the vulnerabilities, and then many hackers just ignore it. But in reality, they thought that there's these kind of vulnerabilities are useless. But state-sponsored attackers were different. So that to get into the Realtek, have you heard about that company? So I believe that's a Taiwanese company, and then they developed the network devices. And then the reason why attackers attacked the Realtek was they want to get the private key of the network driver. Then they can sign any kind of driver for Windows, and then they can easily attack the operating system. Yeah. So to launch that, they actually dropped the USB drive on the parking lot of the Realtek, and then one of the employee plugged the thing, and then internally they can operate the hopping through the malware, and then steal the private key. And then the important thing here is that, so think about it, we can make the people to plug the USB drive here, yeah, and then suppose we propagated the attack, and then suppose we secure the private key, then how can you get private key back to the United States? There's no internet connection. Yeah. And then we need to use this kind of computer who can move around. And then like whenever the computer got connected to the internet, we can send back. And then to do that, so internally, the malware also uses a lot of techniques. So for example, have you ever seen that on your desktop machine? So if the operating system tried to read the disk and some of the light is blinking, and then if there's no disk operation, light is off. And then by synchronizing that disk operation with some of the seconds, we can send 1-bit information, turn on, turn off per each second. So they use this kind of the techniques. So it's so-called the air-gapped communication. Yeah. So it can be done by like the CPU cooling fan too. So on your laptop, sometimes your CPU workload goes up, it speed up the fan, and then it will speed down the fan if it goes to like the low workload. And then if we have 2 laptops, there's no internet connection. But what we can do is this laptop will send the information. And then how we send the information is fast rolling of the fan or turning off the fan at certain second. And then on the other laptop, we just record the audio. If there is a noisy sound, that's 1. No, then that's 0. Then we can actually send information between 2 hosts, even without the network connection. So in the Stuxnet attack, they exactly did not use exactly the same thing, but conceptually, they are using the similar thing to communicate over the without internet connection, and then they can implement something on like the victim's machine, and then if that machine goes to the internet connected places, then they send back the thing to the government. Yeah. So that's how they work, and then another, the more dangerous story is that, so to actually break the nuclear facility, what attack did is there was a centrifuger for like the making their plutonium level concentrated for developing nuclear weapon. And then US government don't know what kind of the machines they are using. So after they get their malware in the facility, they try to do surveillance on what kind of software they are using, what kind of the physical devices they are using, and then get the parameters and do all those kind of research, and then figured out that if they can make centrifuger runs at a certain RPM, then the entire machine will create the physical resonance, and then they will be completely physically broken. So after they realized that kind of thing, they launched the attack, and all the 967 centrifuges take down. Yeah. So this was the first disclosed state-sponsored attack in the history. And then after that, we are seeing the lot of like the state-sponsored cyber attacks. And then one of the examples is that there was a malware named the Dark Hotel. Yeah. And then what they are doing is that they try to hack Wi-Fi routers on the hotel room. And then whenever ambassador or some other president of some country comes to some other country, then they try to hack the communication and try to learn about like what they are doing. Yeah. And then that malware is allegedly written by South Korean government. And then I also have seen that some other guy confirmed that for me. Yeah. So the even South Korean government launched that kind of attack, and then like many other countries are doing that. Yeah. All right. So the interesting point is that in 1970s, 1980s, to do that, we need to shoot the missile. But in this era, the computers are so connected, so we can actually, with the cyber attack, we can actually do a lot of things, and then that eventually make the physical damage, not just the logical damage in the digital world. So this is a serious one. And then I believe like a lecture today is mostly like I'm giving a lecture for the cybercrime. Yeah, but it's for making you all to alert about that. And then as a security, as the person who studies security, and then we need to think about how to defeat those kind of threats, and then how to build the better systems, and then cut off attack chain, yeah, to make the world more secure. And then so these kind of stories are very unfortunate, but what I like is that this kind of thing makes the cybersecurity job much more important. Yeah, and then I don't have to thank to them, but yeah. So the security researchers are getting more valuable. That's a good thing. Yeah. Any questions for the Stuxnet or other state-sponsored attacks? So another example was like the last, although in this year, I believe, there's a vulnerability in the Linux kernel or something. Yeah, I believe so. And then that was a 12-year-old vulnerability. So the 12-year-old means that the code that caused the vulnerability was committed 12 years ago. And then the interesting thing is that the name of the committer, I cannot write on the name of the committer was the character RYUK. And then name of the committer was a Korean name, so that I can identify that. Yeah, but the RYUK, South Koreans never use that name. Yeah, that's YUK. There's no R. That means that guy is a North Korean. Yeah, so it turned out North Korean guy committed to the open source, intentionally implant the backdoor, yeah, and then stay there for 12 years. So that kind of thing still happens. So like we need to do a lot of effort to kill that kind of attacks. And if there's no more questions for the Stuxnet, then this is the last class. And I'm welcome to get any kind of questions in security or computer or anything. Yes.
This isn't really related to security, but I'm interested in hearing about your car.
My car? Yeah. So the problematic thing is that I believe like launching the auto driving in like in the US soil is illegal right now. So please believe me that I'm not driving autonomous vehicle at all. That's just a navigation system. Yeah. And then the interesting thing is that the modern cars are all equipped with a lot of like convenience features for the drivers. For example, we do have an adaptive cruise control. So it measures the car between my car and then car in front of me. And then actually they do measure the car in front of me, in front of the car in front of me. So they actually measure two cars. So that's why even if I cannot see the car ahead is completely stopped, if I'm behind the trailer, I would never seen that. But my lidar can detect that and then stop accordingly. Yeah, That's how like the most of the systems are work. And then another thing is that like the most of the car has a lane departure sensor. So if the so how they works is like they do have a camera at the around the tire or something, and then like if they just watch the line, and then if it skews a little bit, then they just the steer the handle a little bit. Yeah. So there is so what that means is that so there's a power to apply the steering, and also they can change the speed for the cruise control, and then they can measure the distance to the car in the forward, and also they can be at the lane. Yeah. So what that means is that all the capability for the driving is ready. Yeah. But how I think is that this is my personal opinion. So Tesla is doing the autonomous driving, but many people got confused that only Tesla can do that. Yeah. And then another confusion is that many people think that only the electrical vehicle can do autonomous driving. That's not true. That's totally independent thing. Yeah. And then what I think about the why Toyota, Honda, or Hyundai, they are not releasing the autonomous driving is that due to the regulation related problem. Then I believe that they all have the technology. But what I have checked is like so I introduced the hacker GeoHot last lecture, right? So who hacked what is that? The PlayStation 3, right? So now he's working on a company called Comma AI, and then that company develops the making that kind of the adaptive cruise control available car into autonomous driving vehicle. And then what they are doing is very simple. They are not implemented like a new and great technology. What they are doing is that they use just a machine learning to detect. So if the road is straight, then we need to go forward. And then if the road is a little bit curved on the right side, then we need to turn the steering a little bit. And then they just calculate the curvature of the lane and then steer the handle accordingly. And then how they do that is that I actually read the part of the code of that. And then how they did that is like they actually play as a man in the middle. So in my car, how I installed it is like there's a camera that sees the lane. And then there's a plug that directly goes to the Toyota ECU, but it'll be connected to that machine. And then that machine will connect back to the Toyota. And then what this machine is doing is that whenever they need to turn left, so the lane departure sensor can only make the return steering very little bit, not like this, just this one. And then what they are doing is, so it is limited by the hardware. So for the lane departure system, we can only turn just 1 degree or something. And then what they are doing is they send 1 degree, 1 degree, 1 degree, 1 degree, then like this. Yeah. So like in 2019, their driving was not that smooth, but they engineered a lot for now that it works well. Yeah. But their technology is not at the level of the driving in the city. So it's drivable on the interstate or the highway. Yeah. But the important thing is that so many people think that that could be dangerous, but what they are doing is just a little bit of this. So all the forward distance measurement done by the Toyotas, the stock lidar. So I believe like the forward distance control would be okay, but there's a chance that if that device got hacked, it can steer like this. And that's why I have to hold the steering all the time for preventing that.
That's really cool.
Yeah. And then yeah, as a teacher, I cannot say try that. So the important thing is that I would never say that try that, but it's fun. Any other questions? And then I increased the enrollment for the cyber attack and defense in the next term to 40 students. So there are rooms. So if you want to take that class, please register. And then I'm okay with the resolving all the time conflicts because I will do the similar style. So I will do the lecture and then And then after the lecture, there will be 1 hour exercise, but all the videos will be posted. So if you have a time conflict, just let me sign something, then you can take the other class, and then you can study about that at the other time. Yeah. And then that class does not have an exam at all, no quiz, and then all the flag submission. Yeah, that's the only thing. Right, if there's no more question, let's finish the class at here. Then thank you all for your patience, because like for me, this time I redesigned the class, but the problem is that I failed on the time management, because in this term I'm teaching 2 classes, and then that was a little bit burdensome. So thank you so much for the understanding for that. But what I can say is like I tried too hard to like deliver some of the fun and realistic and practical stuff to you. And then I believe like this can be enhanced in the next version. So then spring, the other faculty member, Sangyan, yeah, he will teach the class, and then maybe he will add some of the interesting thing on top of it. And for those who are curious about that kind of material, I will let Sangyan to release his course website to public, so that you guys later can access that to see the updated material. All right, thank you all, and then good luck to your final. And then there's no final in this class, so yeah, have fun, and then hope all have the good holiday season. Yeah, thank you.